Welcome to the Explainer. All right, today we're going way beyond your basic database indexes. We're going to open up the toolbox and look at some high-performance, really specialized tools from MongoDB.
Okay, so picture this. You've built out your collections, you've added the standard indexes you thought you needed, but some of your queries are just grinding to a halt. They're slow. Sound familiar? It's a super common problem. The good news is there's a whole toolbox of advanced solutions just for these kinds of tough performance problems.
Okay, so here's the plan. We're going to look at indexes for complex data. Think arrays and text. Then we'll dive into special purpose tools for unique jobs. After that, we'll cover indexes that help you optimize for scale and storage. And finally, we'll bring it all together so you know exactly which tool to reach for.
All right, let's get right into it. First up, let's talk about a couple of data structures that can be a real headache to query efficiently. I'm talking about arrays and big chunks of text.
So this is a classic problem, right? You've got a document and it has a field with an array of values. Maybe it's product tags or user hobbies. So if you've got a field like tags, MongoDB database, how in the world do you find every single document that's tagged with MongoDB without scanning the whole collection? That'd be way too slow.
That is the perfect job for a multi-key index. Here's the magic. Instead of looking at the array as one single thing, MongoDB is smart. It actually peeks inside the array and creates a separate index key for each and every item in there. It's like creating an index card for MongoDB and another for database. So when you search, it finds that match instantly.
And you know what the best part is? It's ridiculously simple to set up. You literally just create an index on the array field like you normally would. MongoDB sees that it's an array and just handles it. It automatically creates that multi-key index for you behind the scenes. Zero extra effort on your part. It just works.
Okay, that makes sense. So multi-key indexes are amazing for finding exact matches inside an array. But what if you're not looking for a specific tag? What if you need to find a single word, like learning, buried inside a huge block of text, like a blog post or a product description? A regular index is totally useless for that.
Yep, but that kind of job, you need a completely different tool, the text index. This thing is purpose-built for full-text search. It's not just indexing the string as a whole. Oh no, it's way smarter. It breaks the entire text down into individual words. It understands language, so it knows that learn and learning are basically the same thing. That's called stemming. And it even ignores super common stop words like the or and that just get in the way.
And actually, using it is super straightforward. You just tell MongoDB, hey, this field, I want a text index on it. From that point on, you can use this really powerful .text operator in your queries. You just pass in what you're searching for, and boom, it finds all the documents with that word.
Okay, so we've covered indexing, arrays, and text. Now let's shift gears and look at some more specialized indexes. These are like the precision tools in your toolbox, designed for very specific but very common jobs. Okay, here's a big one, geospatial data. Let's say your app needs to find all the restaurants within a 1-kilometer radius of a user. I mean, trying to calculate distances on a sphere for potentially millions of data points, that sounds incredibly expensive and slow if you had to code that yourself. It would be a nightmare, but that's why we have the 2-to-sphere index. It is engineered specifically for this kind of problem. It lets you run these complex, location-based queries like find all points within this circle or find everything inside this geographic boundary, and it does it with amazing efficiency right at the database level. All right, next problem. I'm storing a bunch of temporary data like logs or user sessions, and this stuff should automatically disappear after a while. I really don't want to have to run a separate cleanup script every night just to delete old documents. Is there a way the database can just handle that for me? Absolutely there is. This is what the time to live index, or TTL index, was made for. It is the ultimate set it and forget it tool. You basically tell MongoDB, hey, documents in this collection should only live for, say, 1 hour, and that's it. The database takes care of the cleanup for you automatically. And the way it works is just so simple and elegant. When you insert a new document, MongoDB just looks at the timestamp field you've indexed, it adds the lifetime you specified, your expire after seconds value, and then a background process just quietly cleans up the document when its time is up. It's completely hands-off and automated. Okay, on to our last set of tools. These are all about building smarter, more robust databases.
We're talking about enforcing data rules, making sure your data is spread out nicely when you scale, and being really precise about what you do and don't index.
So, data integrity. How can you enforce a critical rule like every single user must have a unique email address right at the database level? Yeah, you can put checks in your application code, but I want an absolute ironclad guarantee from the database itself. No duplicates, period.
And that guarantee is exactly what a unique index gives you. It's not a suggestion, it's a hard rule. If you try to insert or update a document with an email that already exists, the database will flat out reject it and throw an error. It's your ultimate gatekeeper for data integrity, stopping bad data before it even has a chance to be written.
Okay, let's talk about scaling. Your application is growing, and you know you need to shard your database to handle the load. But how do you make sure your data gets spread out evenly across all those different shards? You definitely don't want one machine doing all the work while the others just sit around.
That is the #1 reason the hashed index exists. It's a clever trick. Instead of indexing the actual value of a field, say a user ID, it calculates a cryptographic hash of that value and indexes the hash instead. This effectively randomizes the data, which is exactly what you want for sharding. It guarantees a nice, even distribution of data across your cluster and helps prevent those dreaded hotspots. All right, final problem for today. My indexes are getting enormous. They're taking up a ton of disk space and slowing things down. Is there some way I can tell MongoDB to only index a subset of my documents? Like, why am I wasting resources indexing inactive users or products that are out of stock?
This is where partial and sparse indexes are just brilliant. They're all about efficiency. The sparse index is the simpler of the two. It will only index a document if it actually has the field you're indexing. If the field is missing, it just skips it. The partial index, though, is even more powerful. You can give it a specific filter, any filter you want, like status equals active or inventory is greater than 0, and it will only index the documents that match that exact condition. In both cases, you end up with much, much smaller and faster indexes. So, we've covered a ton of ground. We've got all these amazing tools. How do you know which one to pick? Well, what I love about looking at it this way is that it's all about matching a problem to a solution. This right here is basically your cheat sheet. Are you searching inside arrays? Use a multikey index. Need full text search? Grab the text index. You see the pattern. It's about seeing the problem clearly and then picking the perfect specialized tool for that job. So now it's your turn. Think about the applications you're working on right now. Are there any of those slow queries that have been bugging you? Are your indexes getting a little too big? Maybe you're worried about data integrity. I'll bet one of the tools we just talked about is the exact fix you've been looking for.
Thanks so much for watching. If you found this useful, be sure to like, share, and subscribe for more deep dives just like this one.